Welcome to the ET302 how-to video for the Comparitor lab, and we're going to build it in Multisim. Here we are in Multisim. Let's build our first circuit. And actually, let's go ahead and borrow from our op-amp circuit. And we'll modify this. Since we're making a comparator, we don't need our feedback resistor or our input resistor. All right, we don't need our AC. We have our power, and we're going to add a 6-volt battery. So let's go to sources, power sources, DC power, take a ground. And that's going to go into our inverting input. And we're going to need a plus 12. Well, since we have VCC here, let's go ahead and borrow him. We're going to flip him vertically. And we're going to put a potentiometer in between. So we're going to go to, we're going to go to basic potentiometer, and it should be a 1K. Good, let's put it in there, and we're going to flip him horizontally so that we can get our output. And let's go ahead and we're going to run our input into the non-inverting. And we need two DMMs. One for our input and one from our output. And we're going to need a couple grounds. Okay, so we're going to check our output voltage with that one, and we're going to check our input voltage with this one, and that looks good. Let's save this as comparator 1, and I'll give it to you in Canvas. Okay, I'm going to say this is comparator 2, and we're going to modify it for the second part of the lab. Okay, so we're going to swap these. So this guy is going to go to the input, and our 12 volts battery is going to go to our non-inverting, and it actually should be 6 volts. And that, here we are at Multisim. Let's build our project 1, our comparator test, using an open collector LM339. So power sources, we're going to need a ground. We're going to need a DC power, 12 volts. And we're going to need two 10Ks, so let's go to basic. And we need a potentiometer. He's going to be a 10K. And we're going to flip him horizontally so we get the output, and we're going to need two 10K resistors. And we're going to need a 1K. We're going to need an LED. We'll use an orange one, no reason. And we're going to need an LM339. So let's go to analog, comparator, LM339. I believe there's 4 in the package, but we just need 1. Good. And let's go ahead and zoom in and finish it up. View, zoom area. Good. All right, so let's move that over there. Let's move that there. We're going to need a 10K voltage divider. We're going to flip him 90. We need this one, flip him 90. And this one we're going to flip 90, and he's going to go to our, and we're going to use a little larger resistor than normal because that's, we have 12 volts, ground, and he's going to go all the way over to our LED. And we're going to put a voltage divider on our comparator. So we get 6 volts onto our pin. And let's flip this one horizontally too so it matches our excuse me, vertically. So it matches our diagram. All right. Yeah, let's move them all the way down. And let's grab a ground. And we're going to ground pin. Actually, we're going to ground pin 12, which is on top here. So let's paste one here. And paste one here on the bottom of our, and let's flip him vertically. Alrighty. And our voltage divider is going to go into pin 4. And let's move that down. Let's, yeah, just leave them there. This is going to go up to our 12 volts. And that's going to go into our input 5, which is our non-inverting. Oops, let's finish this up. Okay, that's kind of ugly, but we'll come back and fix that. It looks good. Okay, let's open up our comparator 1 circuit. Good, that seems to be it. Okay, and we have, it should be 6 volts. Okay, and here we have 12 volts on our potentiometer, and we have a voltmeter and a voltmeter. Let's go ahead and both of them set for DC. So what we're going to do is, this is a comparator, and we're comparing these two inputs, the inverting to the non-inverting. whichever one is larger, it's going to go to that rail. And a rail is almost to the power supply value, either -12 or +12, and it's close, but it's not exactly to the full amount. So let's go ahead and start. Right now we're at 50%, and it could go either way. So let's go ahead and go let's go up, and we're at 6, and we have a positive, so let's go up. Okay, so we have 8 volts here, which is greater than that, so it should go to our positive rail, and it does. So let's go Shift A, get down below 6 volts, which means our inverting input is higher, and it goes to the negative rail, which is not 12, but it's close to 12. Here's part B. I've opened up our comparator 2 circuit, and here we have 6 volts. Let's go ahead and go down. Let's turn it on first. We're at 50%, so we're at 6, so let's go ahead and continue going down. So we got 4 volts, so we have 4 volts going to inverting, 6 volts going to non-inverting, so it'll go to the positive rail, a little short of 12 volts, positive rail. Now let's go the other direction. Got 7 volts, which is higher than our 6, so we should go to our negative rail, and we have -11 volts. That is correct. Okay, let's open up our comparator 3 file and do project 1. So let's file recent comparator 3, see if this is correct. And for some reason, try again. There we go. So here's our comparator 3 design. And let's clean this up a little bit. Let's flip this guy, and we'll tighten a knot. So let's flip this guy vertically with the ground on the bottom. We're going to flip him vertically. 3 is going to go to our positive, and 5 is going to go to our potentiometer, and 4 is going to go to our voltage divider. And then we're going to hook up our... So this comparator 339 is an actual designed to be a comparator, and it's comparing these inputs. Okay, and internally it has an open collector transistor, which means it needs to be powered in order to work. So here we have power, and when we went to the right direction on our comparator, it's going to light our LED because it's adding a ground. So let's turn it on. Alright, so right now, well, let's wait a minute, let's grab a couple meters. And we're going to measure off our potentiometer, and we're going to get a ground. Alright, so let's turn it on. And right now we have 6 volts. Here we have 6 volts because of our voltage divider. So let's see which direction this thing should go. Alright, we're 4 now. Okay, and 4. So 6 volts is greater than 4. So we have it going to the minus rail, which in this case is ground, so our LED lights. So let's start going up. And once we get above 6. So we have 7 on our non-inverting and 6 on our inverting. So our transistor is off and our LED is off. And this is the same circuit as our very last one, except we're replacing it with a light sensor, which we don't have in Multisim, so we're going to call this good. It's essentially the same circuit.